Hey everyone, and welcome. Ever cracked open a statistics book and been immediately bombarded with mean and standard deviation? It might seem odd, but there's a really good reason why these two concepts are always front and center. Today we're diving into why mean and standard deviation are the cornerstones of statistical analysis. Imagine you're trying to describe a colleague to someone who's never met them. You probably highlight their key characteristics: tall, friendly, wears glasses, maybe. Similarly, when you have a dataset, you need ways to summarize its most important features. That's where descriptive statistics come into play. These help us extract the most crucial information. Let's start with the mean or the average. It's a measure of central tendency, representing a typical value in the dataset. Think of it as the balancing point. It's easy to calculate. Simply sum all the values and divide by the number of values. The mean is mathematically tractable, making it useful for further calculations. However, it's sensitive to outliers, meaning extreme values can significantly skew the average. Now, let's talk about standard deviation. This tells us how spread out the data is around the mean. A small standard deviation indicates that data points are clustered closely around the average, while a large standard deviation means they're more scattered. Standard deviation is calculated by finding the average distance. Each point is from the mean. It provides a standardized measure of variability and is absolutely crucial for statistical inference. You might be wondering, why not use other measures like the median, mode, or range? Well, while these have their uses, the mean and standard deviation offer unique advantages. The mean is easily used in mathematical formulas, and the standard deviation gives us a robust measure of variance. Also, when you have a large data set, calculating the median and mode becomes an exercise in searching rather than computation. So while these other measurements give insight, they lack the calculation and statistical power of mean and standard deviation. There are a couple of key reasons why these measures are so often seen. First, many datasets in the real world approximate a normal distribution, sometimes called a bell curve. In these distributions, the mean is the best estimator of the true value. Also, Chebyshev's inequality states that regardless of the data's distribution, at least 75% of the data falls within two standard deviations of the mean. These mathematical properties lend weight to the importance of mean and standard deviation. In conclusion, the mean and standard deviation are fundamental tools for understanding and analyzing data. They are easy to compute and mathematically tractable, and they provide valuable insights into the central tendency and spread of the data. While they may seem simple, their importance cannot be overstated. Ultimately, statistics can be described as the magic of variances, and mean and standard deviation are the keys to unlocking that magic. That's why they're always on the first page.